Hey everybody, hi. Welcome to class today. I hope you guys are having a great day. You will enjoy this class today. Because it's just makes sense and you're gonna like doing it. And once you get to hang up doing it, you're gonna find that it's actually very easy. What we're talking about today is balancing chemical equations. All right, so let's get going here. Guys, take out your notes. Get ready to learn this method with me. All right. So think about balancing chemical equations. Compare it to a seesaw. I'm sure you've been on a seesaw before. Now, a seesaw, it doesn't really work unless you are balanced with somebody else. So if you're on a seesaw with somebody who's say like 200 pounds heavier than you, well, you're not going anywhere, folks. You are just going to be sitting down on the top end, and that heavier person will be there, and you guys are not going to enjoy the ride. But if you're with somebody who's similar to you, you're balanced, you're able to go up and that person go down, and so on. So that is why balancing equations is important. It just Equations do not work unless they are balanced. Take a second and go back here and look at what is a chemical reaction. I know we've talked about this before, but here we go again, just to refresh your memory. Chemical reaction is a change that occurs when two or more substances combine to form a new substance. Simply stated, a chemical reaction is the process where reactants are transformed into products. So let's take water, for example, because that's something everybody knows about. Water, if we wanted to make it, you would need to add hydrogen and oxygen and put them together to react. Okay, sounds simple, but not something I would suggest doing, even if you could do it. Why? Okay, hydrogen and oxygen make water. That's a simplified way to make it. But if you were to add hydrogen gas and oxygen gas, you would get something that looked like this. Ah, that is called an explosion of a blimp called the Hindenburg. It happened in 1911, I believe. It's around that era. And before one of the earliest blimps made, it actually crossed over the Atlantic Ocean. And why it was able to float is because it was made out of hydrogen gas. Hydrogen gas is lighter than air. And because it was lighter than air, it floated, and it floated very well until it hit this telephone or electrical pole here over in South Jersey, actually. And when it did, a hydrogen reacted with the water, and that's what you saw. Uh, so is that something you want to try at home? A simple reaction to make something that we see every day, but not a reaction we typically something we'd want to do. So let's look at this equation then, even though we're not going to be making it. Let's look at it again. So you have hydrogen and oxygen on the left side of the equation. These are your reactants. Okay, they react together, they add them together to combine together to form water. So the arrow means it yields water. So using the symbols to represent chemical change, the left side is the reactants, the right side is the product. And you can add things like if you wanted to add H2 with a G symbol next to it, meaning it's in a gas state. And you can put an L there next to water, meaning it's in a liquid state. Excuse me. And other symbols you can add as well, but we're not going into that right now. The equation H2 plus O2 yields H2O is not complete because it does not satisfy the law of conservation of matter. And let's go review that, because if we don't know that, nothing makes sense in the world. The law of conservation of matter states that matter cannot be created or destroyed. Matter can be changed into one form or another, or it can be converted into energy, but it cannot be created or destroyed. Excuse me. And you cannot take matter and destroy it. You can make it into something else, but you can't get rid of it. What matter we have on the universe is what we've had for millions of billions of years, and we just keep changing it from one form into another. So another example of what we call the law of conservation of matter. It's the water cycle. The water cycle, meaning you get rain from clouds, the rain falls on the ground, the water infiltrates the ground and run off, and some of it evaporates back, some of it sinks in the ground. All of that water was formed, billions of years ago, and is just being recycled every time it rains, even though that one drop of water may take thousands of years to go from in the cloud to back in the cloud again. It's still still a law of conservation of matter because you're never getting rid of that water. So you can always know if equation is balanced just by checking that the number of atoms on the reactant side is the same as the number of atoms on the product side. So our hydrogen, or H2, plus our O2 yields water. So you have 2 hydrogen here, 2 oxygen here, 2 hydrogen here, but only 1 oxygen on this side. So that is not balanced. To balance this, you need to add more oxygen on this side. You put a 2 in front of this water. If you put a 2 in front of this water, you have 4 hydrogens. 2 times 2 is 4 hydrogens and 2 oxygens. Now you balance your oxygens, but you have more hydrogen on this side than you do on that side. So you would want to add a hydrogen on that side. So this is what the equation for making water looks like when it's balanced. Twice as much hydrogen as there is oxygen. 2 hydrogen plus 1 oxygen, O2, equals 2 H2O. 4 hydrogen plus 2 oxygen yields 2 molecules of water. Balance, simple, right? Just got to make sure that the numbers make sense on both sides, and they're all, each element in its own state is the same as it is on one side of the equation as it is on the other. Not very difficult, right? Compared to some other things in chemistry, this is a breeze. So let's make sure that we understand it. And we're going to do some examples, do some simulations to make sure you guys understand this well. Just a couple more things to go over before we do that. Let's look at what other terms we're seeing in equations that are balanced. When we put that 2 in front of the water or in front of the hydrogen, we call that a coefficient. We are adding 2 molecules of water, like the 2 molecules of water that were formed in the equation. The 2 in H2O, like that, is called the subscript. That's part of an atom. Coefficient means you're adding 2 of that molecule to, or you're making 2 of that molecule. So, and what you all need to remember about balancing equations is that the number of atoms on the reactant side is equal to the number of atoms on the product side. Each atom is going to be equal on each side. But one little catch, it has to be the lowest possible ratio. You don't want to have 4 of one and 8 of another if you can do 2 of another and 4 of another. You got to make sure you get the lowest possible numbers of each atom or each molecule there. Ready for some samples? Sure. Let's do it. All right. You have methane, which is carbon and 4 hydrogens, and chlorine gas. You add them together, you yield carbon tetrachloride and hydrochloric acid. Not something you want to try at home as well. So let's look at this equation in its unbalanced form, which it is now. So before you even know if something's balanced or unbalanced, you could just write out each element in this way. On the reactant side, you have 1 carbon, you have 4 hydrogen, as shown here, and 2 chlorine atoms here. On the product side, you have 1 carbon. Hey, that's balanced already. Great. You have 4 chlorines plus 1 chlorine here. That's 5 chlorines there, and just 1 hydrogen here. So your hydrogen is not balanced. Your chlorine is not balanced. So you have to change that. You don't have to do anything to the carbon. It's perfect as it is. You have 4 hydrogens on this side. You want to have 4 hydrogens on that side. So you put a 4 in front of the HCl like that. So that yields 4 hydrogens and 4 hydrogens that way. So what does it do to your chlorines? Putting a 4 here makes this chlorine 4. and you have 4 chlorines there already. You have 8 chlorines on this side here, but you only have 2 there, so you have to put a 4 in front of this chlorine to make this 8 as well. So the balanced equation looks like methane plus 4 chlorine gas molecules equals carbon tetrachloride plus 4 molecules of hydrochloric acid, HCl. Ready for some more? This is simple, right? This is easy. We can do this. Let's go forward. Another simple equation, nitrogen gas plus hydrogen gas equals nitrite, okay, NH3. So N2 plus H2 yields NH3, two N's, 2 hydrogens, 1 N, 3 hydrogens. To balance this, you got to make 2 N's, put 2 N's here, so put a 2 there, that gives you 6 hydrogens, only 2 here, put a 3 in front of that, and you got it. 2 nitrogens on each side, 6 hydrogens, 2 times 3 is 6, 3 times 2 here is 6. Balanced. All right. So I will give you guys a few minutes to practice on your own in another fashion. If you guys go to this website, practice the balancing chemical equations scenarios that are there. There's a couple of samples. It shows you where the molecules are, but the reaction is unbalanced. You add what's needed, and you get a balanced equation. It'll tell you if it's right or wrong. Give you 10 minutes for that. All right, guys, have a chance. Go do it. Okay, great. You guys are done with that? How did that work out? It told you if it's done good or right. If not good, not balanced, it'll tell you what's wrong with it, and you can keep trying. So I hope that helps show you this a little clearer. For the rest of this class, we're just going to keep doing some examples. So the only way to learn this particular technique is once you know how to do it, is to keep doing it till you see it really clearly, okay? So we have phosphorus gas here, plus hydrogen. Phosphoroxygenate is here. So 4 phosphate ions here, plus 2 oxygen ions there, oxygen atoms there, equals 4 phosphorus atoms there and 10 over here. So phosphorus is already balanced, so this is easy. All you need to do is add a 5 here and you are good. That's an easy one there. Another example here. Iron plus water equals ferrous oxide plus hydrogen gas. So you have one iron atom, one water atom molecule, and you have one ferrous oxide molecule, and one molecule of hydrogen gas. So iron is 3 here and 1 there. You got to put a 3 here to balance that out. So you have 2 hydrogens on each side. That's good. You have 4 oxygens here and 1 there. So you have to put a 4 there. When you put a 4 there, you get 8 here. So you would have to put a 4 there to balance it. And that's all you need to do. All right. So I'm going to give you guys a few more examples for the rest of the class to do it. I'm going to put these up. You're going to tell me what to put in next. Look at the equation. Look at each molecule. You have sodium, sulfur, oxygen, calcium, chloride, and then you have calcium, sulfur, oxygen, sodium, and chloride. Guys, just tell me what we need to do to balance this equation. All right. Great, good, excellent work here. You did a great job. So class is going to end now. We're out of time. We'll take a few more sample project problems of this tomorrow when we return. Guys, have an excellent day. Enjoy. Bye now.